So let's see about open well sample problem. So calculate the specific capacity of an open well from the following data. Initial depression head is a 5 meter, final depression head is 2 meter, time of recuperation is 2 hours, diameter of well is 3 meter. Calculate also the specific yield and yield of the well under head of 3 meter. Okay, so already explained you about the recuperation test and other things. So can you just check out this figure once again? So here the H1, you can see the H1 here. So H1 is the depression head. So when the pumping was stopped, and H2 is the depression head after certain period, and T is the time taken by the water level to rise from H1 to H2, and H is the depression head at the time T, right? And also that by derivating we have the uh, formula, that is K is equal to 2.303 into A divided by T, logarithm of to the base 10, that is a log to the base 10 into h1 by 2, and whereas that specific yield of well per unit area is k by a, and it is also expressed in meter cube per hour per meter square. Okay, and also the given the discharge of the well is q is equal to k into h, and where h is the constant depression head. Okay, so with the given data, the diameter well is given, so you can find the area, right? And the time of recuperation is given as 2 hours, and h1 is given as 5 meters, so that is initial depression head, and h2 is given as a 2 meter, that is the final depression head, and h is given as 3 meter, so that is the well under head of 3 meter, right? So that head is also given, and so already we saw in the recuperation test that k is equal to 2.303 into a divided by t into log to the base 10 into h1 divided by h2, and you can substitute the values, and you'll get it in terms of meter cube per hour per unit head. Okay, so now you can use the specific yield formula, that is k by a, which is also mentioned earlier. So you'll get it in terms of meter cube per hour per meter square, and yield of well, in q is equal to k into h, so h is the 3 meters given, right? So under the head, right? And k you have found the value, and now you can find the q, that is the yield of the well. So the yield should be in meter cube per hour. Okay, so now you can try to do a problem with initial depression head as 5.5 meter, final depression head as 2 point, sorry, 3 meter. Okay, so you keep initial depression head as 5 and 5.5, final depression head as 3. Okay, again I'm telling, initial depression head as 5.5 meter, final depression head as 3 meter, and the time of recuperation is 2.5 hours, that is 2 hours 30 minutes. Okay, and the head, okay, keep the head as instead of 3 meter, that is head, yield of well under head of 3 meter, right? So instead of 3 meter, take it as 3.5 meter, and diameter of well, keep as such 3 meter itself. Okay, now try to solve this problem with the given data. Okay, and the next one is find the diameter of an open well to give the discharge of 3 liters per second. The depression head is 3 meter, and specific yield is 1 meter cube per hour per meter square. So And again we are knowing the formula for the open well, that Q is equal to K into H, or Q is equal to K by A into H. Okay, so if you're not aware of this formula and the derivation, you can go to the previous videos and check out the derivations and how it has arrived, or else check out the textbook how it has arrived, and then again step on to the same problem. Okay, so the given the specific yield, we are knowing that K by A, right? So the K by A is given as 1 meter cube per hour per meter square, right? So area, you knowing that pi d square by 4, and H is also given as depression head as 3 meter, right? So now you can get discharge, that is Q is given as 3 liter per second, right? So now all you're supposed to do is that convert it into meter cube per hour. Okay, so in form of per hour, and then you can substitute in the second, that is in the first equation, that is Q is equal to K by A into H, right? So you have found the discharge, right? And then so I hope that you're well aware of how you got this 60 by 60 divided by 1000, right? I hope that you're well aware of it, as you have studied for almost a year with the hydraulics. Okay, the same methodology has been followed here, and so you can have the Q is equal to, that is 1 is the same K by A value, and next is pi by 4 d square, and into the 3 is your depression head. Okay, so with this you can find d square. So ultimately you got the diameter of the open well, which is asked in the question. Okay, so now you can find the diameter of the open well to for the given discharge of instead of 3 liters per second, take it as 4 liters per second, and the depression head, take depression head as 3.5, and a specific yield as 2, specific yield as 2 meter cube per hour per meter square. And now you can try to find d square, d, that is the diameter of open well.